Have you ever sent a message and just marveled at how it gets halfway across the world in basically a blink of an eye? Well, today we're going to follow a single piece of your data on its incredible journey across the internet.
I mean, think about it. You type something out, you hit send, and poof, it just shows up on your friend's screen. It feels like pure magic, right? So what's the secret? What is this invisible highway our information is traveling on?
Well, it's not magic, but it is a really organized process. It's called the OSI model, and you can think of it as a 7-layer roadmap for your data. As you can see here, we're going to start with you, the sender on the left, and follow your data as it gets packaged, layer by layer, sent across the network, and then unwrapped on the other side.
So, where does this whole journey kick off? It starts exactly where you'd expect, right there with the apps you're using on your screen. This is layer 7, the application layer.
Yep, this is the layer we all interact with. Anytime you're writing an email, loading a website, or shooting off a quick chat message, you are actively creating the raw data that's about to start this whole adventure.
But here's the thing, you can't just send that raw data out into the wild. Nope. Just like mailing a real-life package, it has to be properly prepared for travel. And that's where the next few layers come into play. They're basically our digital packing station.
First stop is the presentation layer. You can think of this layer as the universal translator for the digital world. Its #1 job is to make sure that the computer on the receiving end can actually understand what your computer is saying. So, it does 3 really critical jobs to get our data ready. First, it translates the data into a standard, universal format so that any computer can make sense of it. Then it encrypts it, scrambling it up for security so no one can snoop on it in transit. And finally, it compresses the data, squishing it down to make it smaller and faster to send. So this one layer makes our data universal, secure, and efficient. Pretty cool, huh?
Okay, next up we hit the session layer. This layer is basically the conversation manager. It's in charge of opening up the communication line, keeping the chat between the two devices going smoothly, and then closing it down politely when everything's been said and done.
It's got 2 main gigs. The first is dialogue control. Making sure that 2 devices take turns talking and don't speak over each other. The second is synchronization, and this is a really clever feature. It basically drops checkpoints into the data stream as it's being sent.
Now, why is that a big deal? Well, imagine you're downloading a massive file and your Wi-Fi cuts out. You do not want to start that download all over again from the very beginning. These checkpoints, or SYN points, allow the transfer to just pick up right where it left off. It's an absolute lifesaver.
All right, our data's been prepped and the communication line is open. Now, before it can really hit the road, it gets a couple more crucial things. Think of it like this. The transport layer chops it up into manageable pieces and numbers them, just to make sure nothing gets lost. Then the network layer slaps on the final destination address, the global IP address. With all that done, we're finally ready for the data link layer, which is all about the next immediate step in the journey.
The key phrase to remember here is hop-to-hop delivery. So while the network layer knows the final destination, like across the country, the data link layer is only focused on getting the data to the very next device in the chain, which might just be your router. It packages the data for this short trip into something called a frame. And you can see right here how that data gets bundled up inside a frame. It gets a header at the front and a trailer at the back, and these contain the super specific instructions needed to get it to the very next device.
This whole hop-to-hop thing is kind of like passing a note in class. You don't just throw it directly to your friend at the back of the room, right? No, you pass it to the person next to you, who passes it to the next person, and so on. Each one of those passes is a hop, and it's managed by the data link layer. So how does it know where to send that note next? Well, the frame's header has the physical address, also known as the MAC address. In this example here, the computer with address 10 is sending a frame, and that header clearly says the next stop is address 87. It's a very specific, very local instruction. Okay, our digital package is just about ready to go. We have the data, it's been prepped, and it's got both its final global address and its next hop local address. Now for the last and maybe most fundamental step, turning that digital package into a physical signal that can actually travel.
Welcome to the physical layer, Layer 1. Its job is beautifully simple but absolutely essential. It takes that whole frame and converts it into a stream of raw individual bits.
You can see it happening right here. That neat little package, the frame, is transformed into a long string of ones and zeros. This is the language of computers, and it's about to be sent as electrical signals, pulses of light, or even radio waves.
And where do these bits go?
Well, they travel over physical media. That could be a physical guided path, like through the copper in an Ethernet cable, or the glass in a fiber optic line. Or it could be unguided, traveling wirelessly through the air. This is the actual physical road the data travels on. And just like that, after hopping from node to node, our bits arrive at the destination computer. And now the entire process we just watched happens in reverse. It's time to unpack the message.
Check this out. It's the perfect mirror image of the journey out. The data comes in at the bottom as physical bits and starts climbing up the stack. At each layer, it strips off the header that its counterpart on the sender side added, revealing the package inside.
So, the physical layer turns the signals back into a frame. The data link layer reads the local address, realizes, hey, this is for me, and unwraps it. The network layer confirms the global IP address. The transport layer reassembles all the little pieces back in the right order, making sure everything arrived safely. And this continues all the way up until the presentation layer finally decrypts, decompresses, and translates the data back into something we can understand.
Finally, the application layer presents that original, perfectly reassembled message to the person on the other end. Your email pops into their inbox, the web page loads on their screen, the message appears, the journey is complete.
So from one simple click to this complex, layered series of packaging and transmission, every single piece of data follows this incredible rulebook. And this idea, this concept of breaking a huge problem down into smaller, manageable layers, that's a cornerstone of so much of our modern technology. It really makes you wonder, right? Where else in our digital lives are these elegant, hidden structures just working in the background, making the impossible seem like magic?